Pick up a small refrigerator magnet. Now, imagine the entire planet Earth, thousands of miles of iron, rock, and molten core, pulling down on a single iron nail with the full force of its gravity. You bring the tiny magnet close, and with a click, it snatches the nail away. Think about that for a second. A piece of toy plastic from your kitchen just defeated the gravitational pull of an entire world. Why is gravity so incredibly weak? In the world of physics, this is known as the hierarchy problem, and honestly, it is the most embarrassing secret in science. Compared to the other forces of nature, like the electromagnetism in your phone or the nuclear forces holding your atoms together, gravity is a ghost. It is 10 to the 36th times weaker than the others. That is a 1 followed by 36 zeros. If the strong nuclear force was the size of the entire observable universe, gravity would be smaller than a single human cell. For 100 years, we just assumed gravity was naturally thin. But what if we were wrong? In the world of physics, there is another possibility. Imagine, what if gravity is actually a titan, a force of unimaginable power, but we only experience a tiny fading fraction of it? What if the reason you can jump off the ground so easily isn't because gravity is weak, but because it is leaking? Welcome to the cutting edge of 2026 theoretical physics. A new radical framework is emerging from the halls of Harvard and the world's most advanced laboratories. It suggests that our three-dimensional world, the height, width, and depth you move through every day, is nothing more than a thin membrane, a cosmic film floating on the surface of something much deeper. Scientists are calling it the dark dimension. The theory posits that there is a fourth spatial dimension, a hidden room in the fabric of reality. It isn't miles away in deep space. It's right here. It is inside your room. It is passing through your skin at this very moment. But because of its unique geometry, we are stuck to our 3D slice, while gravity, and only gravity, is free to leave. Imagine a massive waterfall. We are standing at the very bottom, catching only a few stray droplets of mist on our faces. We think that mist is all there is, but just above us, out of sight, is the roaring, infinite power of the main falls. We have spent centuries trying to understand the mist of gravity, never realizing that the source of the power is hidden in a dimension we cannot see. But here is the most disturbing part. Unlike the microscopic dimensions of traditional string theory, which are smaller than an atom, this dark dimension is huge. Physicists believe it could be as large as a single micron. In the world of quantum physics, a micron is a continent. It is large enough to hold secrets that could rewrite the fate of the universe. If gravity is leaking into this hidden space, what is waiting on the other side? Are we merely the shadows cast by a much larger, darker reality? We are about to enter a realm where the laws of Einstein fail, where the vacuum of space is a lie, and where the missing mass of the universe might be watching us from a distance of less than the width of a human hair. Prepare yourself. We are going beyond the three dimensions. We are entering the dark dimension. Physics is a precise science. We can predict the movement of planets and the behavior of atoms with incredible accuracy. But there is one number, just one, where science didn't just fail, it exploded. It's called the cosmological constant problem, and it is widely considered the worst prediction in the history of physics. Here is the problem. Quantum mechanics tells us that empty space isn't actually empty, it's bubbling with energy, tiny particles popping in and out of existence every microsecond. When physicists try to calculate how much energy is in the vacuum of space, they got a number so large it defies logic. If that calculation were correct, the vacuum energy would be so powerful that it would have ripped the universe apart in the first trillionth of a second after the Big Bang. There would be no stars, no planets, and definitely no you. But here we are. So why is the universe still standing? For decades, scientists just ignored the error, putting in a placeholder to make the math work. But in the early 2020s, a team led by Kumran Vafa at Harvard looked into the swampland, a graveyard of failed theories, and found a shocking answer. The energy isn't missing, it's being drained. Imagine you have a giant tank of water that should be overflowing, but the water level stays perfectly low. You'd look for a leak, right? The dark dimension is that leak. The radical dark dimension scenario suggests that the reason our vacuum energy is so tiny is that the excess energy is being sucked out of our 3D world and into this hidden fourth dimension. It acts as a cosmic pressure valve. Without it, the weight of space would be too heavy for reality to handle. But this isn't just a convenient math trick. This drainage creates a very specific condition. To balance the scales, the fourth dimension cannot be microscopic. To stabilize the vacuum energy we see today, this hidden dimension must be around 1 micron in size. Think about that. A micron is 10 to the -6 meters. To a human, that's invisible. But to a string or a quantum particle, that is a vast, echoing canyon. We've spent billions of dollars building telescopes to look at distant galaxies, trying to find out why the universe is expanding. We thought the answer was dark energy, some mysterious fluid filling the void. But what if dark energy isn't a thing at all? What if it's just the sound of our universe breathing into a hidden room? We aren't living in a self-contained bubble. We are living in a leaky house, and the wind blowing through the cracks is what we call the laws of physics. But if this dimension is draining our energy, what is it doing with it? And more importantly, if energy can go out, can something else come in? Because the math shows that the dark dimension isn't empty. It's heavy, and it's starting to push back. If there is a hidden dimension as large as a micron, why can't we see it? After all, we can see bacteria under a microscope that are the same size. So why is the dark dimension invisible to our strongest lenses? The answer is both simple and terrifying. You aren't just looking at the world, you are trapped in a slice of it. Imagine you are that ant. To you, the paper is the entire universe. If someone hovers a finger just a millimeter above your head, you would have no idea it's there. To you, that finger is in another reality, even though it's practically touching you. This is our situation. Every atom in your body, every photon of light that hits your eyes, and every electrical impulse in your brain is stuck to our three-dimensional membrane. We are like shadows on a wall, trying to turn around to see the person casting the shadow, but we literally lack the direction to turn. This fourth dimension isn't far away in the center of the galaxy, it is everywhere. It is the space between your atoms. If you could move just 1 micron in this forbidden direction, you would vanish from our world instantly. You would be standing right next to your friends, looking down at them, but they would see nothing but empty air. Scientists call this the bulk. We are the surface, the dark dimension is the interior. But wait, if everything is stuck to the membrane, why is gravity the exception? Why is gravity the only thing that can hear the other room? In string theory, particles like light and matter are like open-ended pieces of string. Their ends are anchored to our 3D world. They can wiggle and vibrate, but they can never let go. But the graviton, the particle of gravity, is a closed loop. It has no anchors. It is not a prisoner of our dimensions. This is why gravity feels so weak. While light is forced to bounce around inside our room, reflecting off walls and reaching our eyes, gravity is constantly leaking out through the ceiling. It's like trying to fill a bucket with holes in the bottom. No matter how much power the universe starts with, most of it escapes into the dark dimension before we can ever measure it. Now, ask yourself this. If gravity can leave our world and go into the dark dimension, what happens to it there? Does it just vanish into an infinite void? No. Gravity is an attractive force. It clusters, it builds, and as it leaks into that hidden micron of space, it is beginning to form something massive, something we've been searching for in the dark for over 50 years. We thought the dark dimension was empty. We were wrong. It is populated by ghosts of gravity, and they are starting to pull on us. For over 50 years, astronomers have been haunted by a ghost. We look at galaxies and see them spinning so fast that they should fly apart, like a carousel losing control. We know there is something there, providing extra gravity, keeping the stars in place. We called it dark matter. We've spent billions of dollars building detectors deep underground, hoping to catch a single particle of it. The result? Nothing. absolute silence. But the dark dimension scenario offers an answer that is as elegant as it is terrifying. What if dark matter isn't matter at all? What if it's just the gravitational shadow of the dark dimension? Remember, gravity is the only force that can travel between worlds. The theory suggests that as gravity leaked out of our universe billions of years ago, it didn't just disappear. It got trapped in that hidden micron of space, forming dark gravitons. These are heavy, stable ghost particles that live in the dark dimension. They don't emit light, they don't have atoms, they don't even exist in 3D space. But their gravity is so immense that it reaches through the wall and pulls on our stars. We aren't looking at invisible particles inside our galaxy. We're looking at the heavy footprints of giants standing just 1 micron away from us. We're like a child looking at a heavy curtain, seeing the shape of someone standing behind it, but unable to pull it aside. But humans are not good at leaving curtains closed. We've started knocking on the wall. Right now, in laboratories across the globe, we are looking for the Great Leak in real time. Scientists are using ultra-cold neutrons and precision torsion balances to measure gravity at the sub-millimeter scale. If the dark dimension is real, gravity should start behaving strangely when objects get close enough. It should suddenly get stronger or perhaps start fluctuating as the gravitons begin to spill into that extra room. And we might have already seen the first signs. When black holes collide, they send ripples through the fabric of space-time, gravitational waves. Some researchers have noticed that these signals seem to lose energy faster than Einstein's equations predict. It's as if a portion of the scream of 2 colliding black holes is being muffled. Where is that energy going? It's escaping. It's bleeding into the dark dimension. But here's the catch. If we can detect them, can we accidentally open the door too wide? By slamming particles together at nearly the speed of light, we're essentially punching the membrane of our reality. If we create a high-energy event small enough to fit inside that 1 micron gap, we aren't just observing the dark dimension anymore, we're interacting with it. We're like a prisoner who has found a loose brick in the cell wall. We're scratching at the mortar, desperate to see what's on the other side. But we have to ask if the gravity of that other world is what's keeping our galaxies from flying apart. What happens to our world if we break the seal? We have spent the last century looking up at the stars, convinced that we were staring into the vast final frontier. But the James Webb Telescope, the Large Hadron Collider, and the strange math of the swampland are telling us a different story. We weren't looking at the whole stage. We were just looking at the paint on the floor. The dark dimension isn't just a scientific curiosity, it is a reminder of our own fragility. If this theory is correct, our entire reality, everything you've ever loved, every mountain, every ocean, every distant sun, is just a fringe effect. We are the thin, vibrating edge of a much deeper, much heavier, multi-dimensional ocean. We are the foam on the waves, unaware of the depths below. But what is the fate of a universe that leaks? According to the math, the dark dimension isn't a static room. As our universe continues to expand, driven by that mysterious tension we call dark energy, the leak might be changing. Some theories suggest that as the 3D membrane stretches thinner and thinner, the dark dimension could begin to grow. Slowly, gravity will drain away even faster. The glue that holds us together might eventually evaporate into the bulk, leaving our universe to dissolve into cold, scattered atoms. But there is a more beautiful possibility. If the dark dimension is full of gravity, and gravity is the seed of life and structure, then perhaps we aren't alone in this layered reality. Perhaps there are other membranes, other 3D worlds floating just microns away from yours. Think about that. Another civilization, another history, another world, so close that you are practically breathing the same air, separated only by a direction your mind cannot imagine. You will never see them, you will never touch them, but you feel them every time you drop a stone and watch it fall. You are feeling the tug of the great beyond. We started this journey asking why a tiny magnet can defeat the Earth. We found the answer in the shadow of a fourth dimension. We found that the missing parts of our universe aren't lost, they are just hiding in the room next door. The more we learn, the more we realize that the dark isn't empty. The dark is full of energy, full of gravity, and full of dimensions we are only just beginning to name. We are Exoplanet X, and as we look deeper into the impossible, we realize that the universe doesn't just have secrets, it has layers, and we've only just scratched the surface. See you in the next dimension.